Our goal here is to solve this logarithmic equation. We have natural logs, and we're using the one-to-one property, which means that if we have two logarithms, one on each side of the equal sign, that have the same base, then their arguments must be the same. So we're pretty close here. The problem is on the left side, we have two logarithms. The good news is they have the same base, right? They're both natural logs, which means they have the base of e, the natural number. So these can be combined into one logarithm using the product property. I know it's product property because these are separated by the plus sign and they have two logarithms with the same base. So let's go ahead and take their arguments and multiply them. 2x minus 3 times x plus 1. So this is two binomials multiplied together, which we can do using FOIL. So 2x times x is 2x squared. 2x times 1 is 2x. Minus 3 times x is minus 3x. Minus 3 times 1 is minus 3. Let's clean it up a little bit and combine like terms. We have 2x squared minus x minus 3 equals the natural log of 42. Now we have one single natural log on the left, one single natural log on the right. So the one-to-one property says that the arguments must be equal. So essentially, we can say that 2x squared minus x minus 3 must be equal to 42. This is now looking like a quadratic, which I'm going to try to solve using either factoring or quadratic formula. Both require them to be set equal to 0. So let's subtract the 42 from both sides. I get 2x squared minus x minus 45 equals 0. Here I'm going to use the AC property because I have my a, the number that's on x squared, the coefficient of x squared, is not 1. So I'm going to multiply 2 times negative 45, which makes negative 90. And I'm looking for factors of negative 90 that add to make negative 1 because b, the coefficient on x, is negative 1. Well, I think if I do 9 and negative 10, that would work because that product is negative 90 and the sum is negative 1. So I'm going to take that middle term. Let's come up here. I'm going to take the middle term and I'm going to split that into a negative 10x and a positive 9x. So 2x squared minus 10x plus 9x minus 45 equals 0. Okay, now I'm going to factor by grouping. And again, if you prefer doing quadratic formula over factoring, that would be perfectly fine on this problem. You should get the same answer. So when this is fully factored, I end up with 2x plus 9 times x minus 5 equals 0. So the 0 product property says I can set each one of these factors equal to 0 and solve them independently. This one on the right is pretty easy. I just add 5 to both sides. I get x equals 5. This one on the left, I've got two steps. I need to subtract 9 from both sides and then divide by 2, so I get x equals negative 9 halves. So these are two potential solutions. I say potential because when we're working with logarithms, we always have to check our work to see if we have any extraneous solutions. So let's check up here. And I'm going to check by plugging in these values into the original function. So let's start with negative 9 halves. So I'm going to plug in a negative 9 halves wherever I see an x plus natural log of negative 9 halves plus 1. I want to see if that's the same as natural log of 42. Okay, so negative 9 halves times 2 is negative 9. And I think I'm just going to do dot, dot, dot here because I already see an issue with this one. This is going to end up being natural log of negative 12. So it doesn't really matter what else I get, plus whatever. because this already is a problem. I cannot have a natural log of a negative number. This is saying e to what power is negative 12, and there is no such number that makes that happen. So this is a problem, which means I do have an extraneous solution. I have to throw out negative 9/2. So let's check 5, doing the same process. It's always super important to check your logarithm equations because of that reason. Okay, let's check and see if this works. So here I have 2 times 5 minus 3, so 10 minus 3 is 7. And then 5 plus 1 is 6. And you have two options here. You could go to your calculator and you could type in natural log of 7 plus natural log of 6 and see if that's the same as natural log of 42. Or I can recognize, again, I could use product property because I've got 2 natural logs, so they have the same base. So I can multiply their arguments. 7 times 6, natural log of 42. 7 times 6 is 42. So natural log of 42 does indeed equal natural log of 42. So it looks like x equals 5 is a valid solution, and that's going to be my final answer.